Very welcome, everybody, to this workshop, which is about teaching statistics to social science students. And it has a particular focus on teaching mixed ability and less enthusiastic students. When I was preparing myself for this presentation, one of my first year students in anthropology, I remembered, and she said, I think it's about 15 years ago when I started out as a teacher in statistics, she said to me, well, trying to teach me statistics, that is like trying to fit a square peg into a round hole. And well, I think that's a saying that fits this workshop pretty well. So I used it as a sort of guideline throughout this workshop I will present this morning. It will take about 1 hour, I guess, to present what I brought with me. It's about 20 slides, and they are about how to teach statistics to students who, well, in the title it's called Mixed Ability and Less Enthusiasm, but well, I think in plain words, we are dealing with students who do not like statistics, not very much, or not at all. Before I continue, I'd like to introduce myself a little bit more. My name is Manfred de Grotenhuis. I know that my last name is quite difficult to pronounce, so I think the first name will do. In English, it's Manfred. I am from the Radboud University in Nijmegen. That's a city in the Netherlands, east part of the Netherlands, very near the German border. Well, before I let you in on the views I hold about how to teach these particular students statistics, I'd like to tell you a little bit about my own educational career, because I believe that my views I hold on statistics are related to my own educational career. Well, in the Netherlands, where I come from, elementary school is between the age 6 and 12. After that, I attained a lower secondary school, which is between age 12 and 16. After that, I attained vocational school. It's a technical vocational school to become an electronic engineer. I graduated from that school when I was 19 years old. So I started working in engineering for about 2 years. I brought along a picture of my own toolbox I had way back then. I worked at a very large factory, and when an engine broke down, we had these bikes with the toolboxes attached to it, and we used them to bike to the machinery that went broke, and tried to repair them. Well, after these 2 years, I came to the conclusion that it didn't really work out for me. So I decided to go back to school, and I attained college at the age of 21. After I had 1 year of college, first grade. Some people advised me that it would maybe be wise to go to a university. They thought it might fit me. So I entered Radboud University, where I still work, when I was 23 years old, and I was interested in things like psychology and anthropology and sociology, and the last one was most appealing. So I decided to study sociology. I graduated in 1994, and then I was invited to write a thesis, which was something between statistics and sociology, or a mix between those two, which in fact was rather tailor-made for me because I had this technical background. So I started writing this thesis when I was 27. After I completed my thesis, which was in 1999, when I was 32 years old, I got a job as a junior lecturer on statistics, and well, from here the story actually starts. Um, I'd like to tell you a little bit about my first 2 years as a junior lecturer. We used a book called Statistics. It is by McLeave and Dietrich and Sinkich. And I still think it's a good book. It covers statistics well. It's clearly written, rather technical though. It's in English, which was a disadvantage for my Dutch students, and it has rather crowded pages. Well, I brought along the 7th edition, which I used way back then. It has the cover with some jazz musicians on it. I never understand why these covers, these photos on these covers not really related to statistics, but well, here it is. Well, my students way back then, they came from sociology, anthropology, and communication sciences. And well, there are very enthusiastic students about their own research field, but one can say that well, they do not like statistics very much. Way back then, so it's about 15 years ago now. We did not use SPSS, the statistical program that has all the statistical analysis in it. It's a very popular package, of course. We didn't use it in the exams. Instead, students used the calculator. And well, I have to admit, we had rather poor results. I think about 40 to 50% passed the exams. Well, I think most decisive was when a student in anthropology came to me after I finished class, and she said to me, "Well, the way you explain things is okay," and she might be able to calculate something like chi-square during the exams when asked to, but well, to be honest, she said, I do not have any clue whatsoever what it means, something like chi-square in her field of research, and she hadn't a clue how to use it. Well, to me, that really came as a blow, and after that, I really started thinking about how we should teach statistics to these students who are, like I said, they are very enthusiastic about their own field, like anthropology, but statistics is really a problem for them. So when I was, thinking about how to present these views I have, I went back in my memory, and I must say I didn't actually write down all the things that happened 15 years ago, so I had to recollect it from my memory. But if you ask me what went wrong during these first 2 years, well, I guess that we did actually everything to live up to their worst expectations. I think they expected something with formulas and calculations, and well, we did so. Further, they expected that it was going to be difficult, very hard to understand, and that it would not have any connection to their own study. And I think that was true. They also expected, theory on statistics, mathematics, and no practical tools to use it. And well, again, I think that was true. Well, it was almost true. Well, I think if we have to wrap it up, I think if you want to say it something in a way like to fit the square pegs, I think way back then we used a hammer. I think we as statisticians, we taught statistics to students, and we did not take into account their own background, where they came from, their interests were, what their field of research was going to be, or what their past or future courses were, what they already had been taken, or what was to come. So I think we simply ignored that, and we just taught statistics the best way we could, but we ignored, the things that I just summed up. But it was statistics and nothing more. So when I went looking for a solution, I asked myself, what kind of students actually do we teach statistics? And furthermore, what do they have to know? And third, what do they have to be capable of? So it was trying to figure out what these students are like, and what the research field they entered is like, and what knowledge they actually needed for their own study, and what actually did they have to do to be capable of, or the practical side of it. So these are, I think, the three main questions which are important and had to be answered before I could go on teaching statistics to them. Well, again, when we take the square pegs, then I do not think that using a hammer is very efficient. So I think a better way is to change it around and just accept that we are dealing with square pegs, and that we just have to adapt the holes to make it fit. To make it fit, I started using examples that fall into the field of their own interest. So when I'm teaching to students in anthropology, it is quite something different than teaching statistics to someone from, say, psychology or sociology, because their subjects are quite different from each other. So I started using particular examples from their own field of research. So as a consequence, I started talking about Aboriginals when it comes to anthropology, about watching TV, and the time they spend watching TV. That's something that is related to communication sciences. And I started talking about life expectancies way back in 1899, which is a subject within the field of sociology. And I didn't, more or less randomly choose these topics, but I took them from courses that they already had been taken. So the examples, and well, I'm one of the people who think that real data are important. I mean, you can make up data if you like, but I prefer the real data from real people. So I started collecting all kinds of data from these fields of anthropology and communication science and so on, to be used in SPSS. That's I think one of the most popular statistical packages, and rather user-friendly. Way back, or in our university, we have a tradition to use SPSS. I think that it is a program that is most suitable for these students. And I also focused on SPSS output, and also on the way to obtain the output. You can obtain the output, of course, with using the menus in SPSS, but you can also use the syntax. So both ways I use myself. And well, this SPSS output and the way to obtain it are discussed during class. That was another thing that I changed. So I started to use examples from their own research field, and I incorporated SPSS far more into our classes than we did before. Well, besides that, I changed the examples and I incorporated SPSS far more than was done in the past. I also reworked the assignments. I started to use weekly assignments, which were related to the examples I already taught during class. And students were invited to analyze and interpret and to write about these examples. So I offered them data sets, and I said to them, well, you heard about how to present these quantitative variables, and here we have a particular data set, so you are invited to present the variables to an audience and write about it. One other thing I changed was that attending classes and doing these weekly assignments was compulsory. So, I mean, it looks a bit for some like university. It seems not very necessary to do something like a compulsory thing on attending classes and the weekly assignments. But I do think because enthusiasm is especially in the beginning is quite low, you somehow have to persuade them, and I think it works best when right from the start attending classes and doing these weekly assignments are compulsory. Otherwise, I think it doesn't work the way you want it to. Well, then I also changed the exams. Like I said before, it was in the beginning it was very concentrated on the statistical theory and not so much on the practical skills. So I integrated, I tuned down a little bit on the theory, and I focused a lot more on the practical skills they have to have during their the courses they are taking later in the year. Okay, well, that's sort of, what I was rethinking and reworking after this student came to me and said, well, yeah, you explained it quite well, but I don't know how to use it and what relationship it has to my own field of interest. So I changed the examples, incorporated SPSS, made attending classes and the weekly assignments, they were made compulsory. And I also changed the exams. I changed the focus from theory far more to the practical skills. Now, before I continue with a weekly scheme and things like that, just to give you an impression how I do it is, I will walk you through a example, and I will tell you a little bit about a assignment and the exam. So I just present them to you, so you get a better picture of what I mean about teaching statistics to these students. Well, one of the examples I brought with me is about the age distribution in the Netherlands in 1899. I show this example to students in anthropology and also students in sociology. It is related to one of the most important key concepts, I think, in statistics, which is the central limit theorem. And I noticed that for students with mixed abilities and less enthusiasm, this central limit theorem is very hard to crack. So I put in some effort to explain it to these students, and well, I think that using this example for many of them, it suddenly becomes rather clear how it works. So I just walk you through it to give you just a impression how I teach statistics. to these students. Well, what you see here is the age distribution way back in 1899. I collected these this data from from Statistics Netherlands, which is a bureau that collects data from the Netherlands. One of the things they collected was the census data from 1899. Way back then, all the people in the Netherlands, the Dutch people, were asked to fill in a questionnaire. And one of the variables that was on it, or one of the information parts that was on it, was the age of all the people in the household. So we have about 5.5 million cases, and they all stored on a webpage. And you can just go there and download the data. So that is exactly what I did, because I wanted to start out. Many books in statistics do not start from population data, but I think to understand something like the central limit theorem is important. It is important to start out from the population. So this is what I did, and to this distribution also comes a mean age, which is 27.1 way back then, and the standard error as a measurement of variation is 20.6 years. And well, students find this interesting because it doesn't look anything like the distributions we have nowadays. It is not this triangle anymore. So I think you have your attention when you present something like this. Here is this distribution again, and well, it is some years ago, but way back then, playing darts was rather popular in the Netherlands. I remember something like the Embassy, where Raymond from Barneveld, one of our Dutch players, was rather doing well. So from that, I think I stole the idea of playing darts. But this time, playing darts is very special because we do it blindfolded. This is how to. This is my way to explain to students what a random sample looks like, because I invite one of the students to throw a couple of darts towards this distribution blindfolded. This is what I show actually to them, and then I ask them, well, if every dart picks one person out of this distribution, what will the distribution look like in a sample of, say, 100 darts? So they threw blindfolded these darts, and it is very interesting that which is, of course, that it will look very similar to the triangle in the population. Many young people, and the older they are, the less they will be found in the sample. So by doing this, I explained that the distribution in a sample tends to look like the distribution in a population, which, like I said, it's many students have the answer right. Well, of course, then I say something about that this particular sample has a mean age of, say, 27.8, which is not exactly equal to the population parameter. So we get a next question, and we say, if we take many of these 100 dart samples and we calculate a mean age for each sample, what will the distribution of these mean ages look like? Well, and to my surprise, who come to, well, they not say a normal distribution, because they do not have a idea of what a normal distribution would look like, but they have a certain idea that this might be shaped in like this. It's some sort of clock type of distribution. So when I say to them, well, this is what statisticians call a normal distribution, they're not really surprised. When and here comes a tricky part. We have to explain that this way of sampling is not biased, and we give the expectation. So say the mean age of all these mean ages equals the age in the population. And of course, we have to say something about the variation of this sampling distribution. And I explained to the students how this has been calculated. So taking the original standard deviation in the population divided by the square root of the sample size, which happens to be 0.65. So from here you can, explain that there is a relationship between the variation in a population and the variation in a sampling distribution, just starting out off from this population data, which I think is for this kind of students a sort of eye-opener to them. Then after presenting this sampling distribution, which, like I said, doesn't really come as a surprise to them, we can take it one step further and say, okay, if we take certain boundaries, which of course are related to the 90% confidence interval over here, then we can say something like, okay, if we take these boundaries, then you will find 90% of all the samples within this distribution, which actually comes as, well, not really as a surprise to them. The only thing that these students wonder about is, yeah, but why do we do such a thing? Why do we come up with these 90% boundaries or 80% boundaries? So the question is, yeah, sure that you can calculate things like that, but what is the use of it? Well, I come to the thing that I'm not really teaching them to calculate these confidence intervals. I mean, that's okay if you like to make a prediction about how it is in the population, but in our university, emphasis is more laid on testing hypothesis. So I just, from these confidence intervals, I go to what I think is core business, and that is stating a research hypothesis. In this case, I came up with the idea that compared to 1899, in 1930, the mean age has risen compared to 1899. Which is a research hypothesis that is not really surprising to them. They know that medical care and welfare has risen over time. So one may expect that the mean age is no longer this 27.1, but that it indeed has risen. Of course, then we have to deal with the null hypothesis, which of course says that the mean age did not rise between 1899 and 1930. Now, what I do next is that I present the normal distribution again, and I say, well, suppose that you had a sample in 1930, and the sample comes up with a mean age of 28.4, and I can show that this 28.4 lies within this rejection area of 5%. So they calculated the 90% interval. But we're not interested actually in the interval itself, but we are interested in the rejection area, which of course is the other side of the coin. But I do so because SPSS comes up with the probability, which is also over here on this slide. The probability to find 28.4 or more is 0.0228. And I explained to these students that the probability, when it is equal or lower to the alpha, to our criterion, then we have to reject the null hypothesis. So in the end, when I explained to them how the central limit theorem is working, then we can actually going to test hypothesis, and we say, okay, we found this 28.4 in the 1930 sample, and it is within the rejection area of 5%. So we can say that with a certain uncertainty, of course, that between 1899 and 1930, the mean age most probably did rise. And so it confirms our research hypothesis and rejects the null hypothesis. Well, I mean, what I just did is what I walked you through a example, which is, of course, about the central limit theorem. And when I explained this to them, they get more or less the hang of it, and they say, okay, so that is what it's all about. And they are a little bit surprised to find that it is just this, and not that it is particularly complicated or something. And I think they find it not very complicated because I started out from a population example, and then I went down to collecting one sample, and from that one sample we derived some conclusions. So that is one of the examples I use within classes of anthropologists and sociologists. Well, the example I just presented to you is from Statistical Tools. It's a book I wrote a couple of years ago based on my experiences I had with students in anthropology and sociology. So it more or less, it doesn't have any emphasis on formulas. You can find them in some endnotes, but they're not really important in the text itself. I also included a web page on the internet, which has all the figures and tables in data files. Like I said, I do not like the making up the data, so I came with examples from real research. I also included exercises, which are not part of the book, because I think that if you include them in the book, they take up a lot of space. So the book is going to be more costly, and you can adapt the exercises far more easily. So I kept them out of the book, and I just included them on the internet. Further, it gives me the opportunity to include more statistical applications, and also some things in some programming in SPSS syntax. So that is what I did. I actually came up with a rather thin book. It is about 140 pages, I guess. This Statistical Tools book. I brought 5 copies along. So if you are interested, you can have one if you like. And maybe you'd like to visit the web page as well, because of the examples and the exercises and so on. If you are interested, this is the URL to find the information. Well, like I said in the beginning, I think it's important that students are also capable of analyzing the data themselves. So I put far more emphasis on the practical side of it. So I decided to use all the data which I use in my own books. They're about real data. I didn't make up any data, and so I translated all the data I've got into SPSS data files. One of them is a figure out of one of my books about statistical tools, and it's about the age distribution. I have here on the slide the SPSS syntax to generate the distribution. This syntax I use not so much for anthropologists, but for sociologists I do. Also for the students with mixed ability. I think syntax, they have an idea that it is very difficult to do, but if you take a look at the SPSS manuals, then you get a confirmation of that. But I rewrote parts of the manual, and it's now part of a book called How to Use SPSS Syntax. I brought along also a couple of copies. If you are interested, it's going to be published with Sage after this summer. So if you will execute that particular syntax line, you will get the age distribution I showed you some slides ago. I invite students to sort of, do this research on your own and use this SPSS data file and come up with the distribution, and also calculate some interesting parameters like mean age or the median or standard deviation. So what I actually teach them during class, the data I use, they can download themselves, and they can analyze the data themselves. Well, there is another example I brought with me. Like I said, testing hypotheses is one of the central themes within our department. So it's important that students are capable of testing these hypotheses. One of the hypotheses they test is about the number of kids in the Netherlands. I put here on the slide one of the hypotheses which state that the average number of children in the Netherlands is below 2, and I ask students to test this hypothesis within SPSS, and of course you can do this within the syntax program, or you can use the menus. I'll say something more about the menus in some minutes. But first off, I like to present the one sample t-test these students have to use during their assignments. So I put some emphasis on testing the null hypothesis, which states that in the years 2010, I think the average number of kids in the Netherlands was not below 2, so the test value is 2. And I asked them to take a look at the difference from that null hypothesis. As you can see in the sample, the average number of kids is below 2. And furthermore, I asked the students to take a look at the t-value, and more importantly, to the probability, which happens to be very low. So I trained them actually to perform this t-test on a mean themselves using SPSS, and I also trained them to read these tables in a proper way, and I hope, because the example, the average number of kids in the Netherlands is related to some topics they have within other courses, that they are more enthusiastic about testing these hypotheses. And I told them a little bit about the background, the central limit theorem. Not so much the formulas, but more the basic idea behind it, starting from this population distribution. And well, in the end, they are capable of testing these hypotheses, and they know what kind of assumptions lie behind it, and they know what to do and what not to do. Without really knowing what kind of formulas are behind all this. I do believe that that is of lesser importance than having the right statistical analysis and have the right interpretation of the table you come up with. Well, like I said, there is some discussion whether you should use syntax or menus. What I do actually, and I'll come back to that in some slides which come after this one. I cannot present a book in English. This is the Dutch version I wrote. It's about using the menus in SPSS. It's also very not very page book. It's about 120 pages about the main menus within the SPSS program. And I use this for anthropologists and for sociologists in the first year. Basically, it's a book that has this kind of structure. It's full of screenshots of SPSS program, and to get these screenshots, there are some instructions in the book, like this one. This is just an example to give you an idea. This is about addressing missing values. I just as an instruction, I came up with what to do actually to get this score 999 as a missing value. And if you do it all correctly, then you come up with these screenshots, and so students can check by themselves whether they done it correctly or not. This way, actually, this book tells its own story. I mean, you do not have to be in class while they are working on this book. So it's written for our first graders, which I think if you are dealing with these first graders, that you cannot just jump to SPSS syntax. That's just I think that is not the right way. I think it's more efficient to start out with the SPSS program and using the menus, and in a second year start with the SPSS syntax, or just continue with the menus. But later on in their courses, they are asked to do more complex analysis, which I think that SPSS syntax is just more efficient to do so, and you can also ask them to show the SPSS syntax they used, so you'll get a more accurate impression about what they actually were doing. But when they're fresh students, I always start out with the SPSS menus, and I think that is for students in this when they are at this point in their educational career. That is, I think that's good enough. But like I said, I think it's important that one uses weekly assignments, which are compulsory when you are dealing with these students, because they have all kinds of ideas about statistics, which may not be right, but they some of them have a very negative attitude against it. So I think to just get them into the course and get them more enthusiastic it's very important to do these assignments in a compulsory way. Otherwise, you have students who will resign from it, and that's not exactly what you want. So that's why I choose for a compulsory structure. Just to give you a idea about the weekly assignments, which like I said, can be found on the internet, I use a set of exercises which are related to my book, and which are related to SPSS. So I take the statistical theory and the practical application together in one assignment. Well, what you see here is the very beginning of a set of exercises. I just want these students, or ask these students, to download a data file from the web pages, and then I just ask them a couple of questions, like I showed over here on this slide, like how many units of analysis are stored in the data file. So they take a look at the data matrix. I mean, those students have no idea whatsoever what a data matrix looks like. So I think it is just a good idea to start at the very bottom, and ask those students to just take a look at the data matrix, or the spreadsheet as you want, and just take a look at it and tell me how many units of analysis are actually in that particular file. Well, Another thing that and I mean this assignment becomes a little bit more complex than I can show you here. But one of the questions is how many men and women are in the file. So then students are asked to come up with a frequency table, which of course can be generated using the SPSS menus, or you could use the syntax. But in this case, it's an assignment from the first year, so they can use the menu. And this assignment, like I said, it continues with all kinds of questions about how to describe the data set. It has nothing to do with inferential statistics. It's just descriptive statistics. I'll come to that later. If you like to take a look at these particular assignments, they can be found here on these web page. Well, the last thing that I did change was the way we took the exams. I choose to go for a multiple choice exam, and this exam was a combination of theory and practice. To be honest, I downplayed the theory a lot, and the focus was much more on the practical side of statistics. Just to give you an idea of how this exam looks like, I included in this presentation question number 5. Question number 5 is about whether a student has the right ideas about statistical testing and the relationship between the population and the sample. The question before this, question number 4, was about running a regression analysis, and the dependent variable was weight, and one of the predictive variables was body length. So in question number 4, they were asked to run the regression model, and a question was asked about the parameter itself. So question number 5 is about the relationship between the sample outcome and the population. So there is someone who argues that the effect of somebody's body length on weight maybe was found in research, but it also implies that the effect also exists in the whole population, and students are asked to reply to this. Well, I included 4 answers to this, and I'll just walk you through to give you an impression of the type of responses. The first response is that the student is not sure about the effect because only 1,000 respondents took part in the sample. The second response is that the student is pretty sure that the effect exists in the population as a whole because a random sample was used, and this random sample was sufficiently large. The third answer is that the student is not sure about the effect in the population because the statistical probability is very low. And well, the last response, which is the right one, reads that the student is pretty sure that the effect exists in the Netherlands as a whole because the t-value that was found in the regression analysis was very large, and students have to be aware that if the t-value is very large, then this is a significant outcome, and there is a fair chance that the effect also exists in the population as a whole. So that was just one of the questions during the exams. I use 30 questions in the whole exam, and the exam takes about 2.5 hours. So we have 30 multiple choice questions, which include theory, like this one, like this question number 5, but it also includes very practical questions about just running a statistical model. Okay, well, before I end this presentation, I'd like to give you a very short overview of two courses in statistics. One is introductory and one is a follow-up course in statistics. So about the introductory course in statistics, this course is given in the first year in the field of anthropology and sociology and also communication science. The course stretches over 9 weeks. We have a lecture which takes 2 hours a week. 90 minutes of it are reserved for theory. Of course, it's not very hardcore statistical theory. The formulas are very downplayed, and it looks very much on to the example I presented here today with the central limit theorem. So it's more it's not so much on the formulas, but more on understanding how it works. The remaining 30 minutes are related to the assignments. So I explain and show how the answers could be found. The assignments are so-called take-home assignments, and on average they take about 3 hours work a week. Well, I just continue with a little overview of what is the subject per week. The first week we have an introduction to descriptive statistics and an introduction to SPSS, the statistical program we use. Please note that it is only on descriptive statistics. The inferential statistics are in the next course, the follow-up course, so we restrict ourselves to purely descriptive statistics in this course. The second and third week I solely talk about SPSS, so it is only using the menus, so no SPSS syntax is involved at that stage. I think that is something that can be applied in the second year. So this SPSS training takes us 2 weeks. We introduce the students to something like a data matrix or the spreadsheet, which is something that's completely new for them. So I want them first to have some understanding of the statistical program before we continue with the statistical theory. Well, then we have the fourth week. We start with graphical descriptions of qualitative and quantitative variables. So we explain what a bar chart is, scatter plot, box plots, stuff like that. Then we have week 5, where we have the numerical descriptions of qualitative and quantitative variables. So we have mean, median, modus, standard deviation, variance. So that kind of subjects we address in that 5th week. In the 6th week, we move over from descriptions of one variable to the description of 2 variables and the relationship between them. So we have in week 6 the relationship between 2 qualitative variables. It's basically cross tables presenting chi-square and Kramer's phi and Kendall's tau and the Spearman correlation coefficient. Then in week number 7 we switch to a relationship between 2 quantitative variables. So we talk about the Pearson correlation coefficient and linear regression analysis. Week 8 we have something special. We address some time on constructing so-called Likert scales, and we also talk about how to write a paper with descriptive statistics, because parallel to this introductory course in statistics, there is another course that deals with collecting data. So first year students are asked to take an interview with the inhabitants of our city, Nijmegen. So we have a random sample, and the students are invited to interview some of the people we randomly sampled with a structured questionnaire. and we asked the students um, to get the data into SPSS, so to analyze it. And for that project, they also need the summation of some variables. So that's why the Likert scales came in here, and also some topics on how to write a paper with descriptive statistics is addressed in that last week. And the last week we use for a summary. Of course, in all these weeks we have our assignments as well. So we also address questions from these assignments. So at the end of this course, we have I think the students know a lot about SPSS and how to use the menus, and they know quite a lot about how to describe variables. So it's not about inferential statistics. I think that that should be in another course for these students. So that's a main overview of an introductory course. Well, then I like to show you how a follow-up course in statistics looks like. We have again 9 weeks, but we have a little bit more time on the lectures. We have 2 hours a week of theory, which is again not so much on the formulas, but more on how to understand the theory. And we have 2 hours a week dedicated to the assignments. Again, these are take-home assignments, and it takes again 3 hours of work. We have in week number 1 a introduction to inferential statistics and SPSS using syntax. So this time we changed from menus to using syntax, and we introduced the inferential statistics, and from that I took the example of the age distribution in this workshop. Then we have in week number 2 a one sample test for mean, as I showed in this workshop. It was the test for the number of kids in the Netherlands. Week number 3 deals with the one sample test for proportion, and then in the 4th week we have comparing of 2 means, which can be paired or non-paired data. Then week number 5 we have the analysis of variances, or ANOVA. Week number 6 deals with the associations in a contingency table, which again deals with Kramer's phi and chi-square and exact tests and stuff like that. But this time we have also the probability test that goes along with it. Then in week number 7 we deal with linear regression analysis, which is more or less deals with the simple model, just one predictor variable. And we learn our students a little bit more about the assumptions behind linear regression analysis. Then we have in week number 8 the linear regression analysis again, but this time it's multivariate, meaning that we have 2 or more predictor variables, and we go into selection criteria like the stepwise method, and we talk about causal modeling, about spurious relationships, for instance, or interaction models. And in week 9 again we have a summary. Again, in all these weeks we have our assignments that deal with real data and are connected to the subjects I told you about. So this follow-up course is a little bit more time consuming, and it's more difficult, I think, but because they already had this introductory statistical course, this is something that follows quite naturally. So at the end of this presentation, I'd like to give you a short summary. What we are dealing with here was teaching statistics to mixed ability and less enthusiastic students. And we talked about the square pegs and the round holes. I think that this is not true. In my experience, we can teach even students who are not very fond of statistics in the beginning, or have the idea that it's not going to be very much fun. We can teach them even quite complex statistics, and this can be done if one takes into consideration the topics of their research field. I think that is of great help if you are able to connect the statistical framework to the topics they already learned about. Then I think it's our task to show how statistics can be a useful tool in their research field. So I think the attention shifts away from explaining how a formula works to the idea of how you can apply statistics to your own research questions, which is, I think, quite a different view on it. And I think parallel to this, I think one should avoid mathematics as much as possible, because if you do so, if you focus on mathematics, you just I think you're doing the wrong job there, because they're not really into these mathematics, and it doesn't serve any goal here, because you want to train these students in how to apply statistics in the right manner, and which formulas exactly all lie behind these statistical applications. Well, to me, that is of minor concern. The other thing that is important is, I think, that one has to use weekly assignments, preferably compulsory, with a clear link to the field of interest. In my opinion, the statistical package SPSS is a perfect workhorse for that purpose. So with these 4 reminders in the back of our heads, I think one is able to show that statistics can be very useful also to students who are not really into this statistical stuff, and well, maybe even at the end of the courses get enthusiastic about statistics. And I think if that is the end result, then we can be very satisfied. Well, this brings me to the end of my presentation. Hopefully, with this presentation, I was able to convey my views on how to teach statistics to students with mixed ability and less enthusiasm. I mean, the biggest reward that a teacher, in my view, can obtain is that students say, well, I thought that statistics would be rather dull, but after attaining the classes, I come to an opposite conclusion. That would be great, of course. Yes, I do believe that if we relate our statistical knowledge to the field of interests of these students, and related to assignments, weekly assignments, and include SPSS to it, then I think that even these students, which have, before they enter class, they have this idea about statistics, that it's going to be dull and not interesting, and something that you have to do because well, it is prescribed. That they change their attitude and view statistics in the end as a very useful tool. I mean, that would be great, I guess. So with this last remark, I'd like to end this presentation. Thank you very much for viewing my PowerPoint presentation and for listening to it. Thank you very much.